Assalamu alaikum dear students. Today our topic is matter around us pure? In this topic we are going to discuss about the different things which exist around us and to see whether they are pure or impure as far as their chemical composition is concerned, or we can say according to the chemical nature of their constituent particles, because every kind of matter or every kind of material is made up of the constituent particles. First we will see what is the pure matter. Pure matter is the material or anything which consists of only one kind of the particles. So the chemical nature of the constituent particles is same. Say for example, water, glass of water, some quantity of salt, some quantity of sugar. These are the examples of the pure matter. I will explain you them one by one. First, we will take a glass of water. We know the water molecules are present in this glass of water. So it is made up of only one type of particles, that is the water molecule. So this we are taking this matter or material which is the water. In this material everywhere we find the H2O molecules at the top, in the middle, and also at the bottom. So it is made up of only one kind of the constituent particles, which is the H2O molecule. Similarly, we are taking the example of some quantity of the salt. We are taking the quantity of salt. Say this is the quantity of salt. In this quantity, at every place we will find the NaCl molecules. Here we will find the NaCl molecules. In the middle we will find the NaCl molecules. Here we will find the NaCl molecules. So everywhere there are the NaCl molecules. That means it consists of only one kind of particles, or the chemical nature of the constituent particles is same, that is the NaCl. These are the examples of the pure matter. Now we will take what is the impure matter. Impure matter is anything which consists of more than one type of particles. However, the chemical nature of the constituent particles is not the same. That means it is composed of, or it is made up of, many types of particles, which will be more than one, two, three, or four. For example, we are taking the case of the milk and salt water. These are the impure matters. Why? First, we will take the milk. Milk consists of three types of particles. First, protein. Number second, fat. And third is the water. These are the three types of particles present in the milk. So milk is not the pure matter, as there was the salt, some quantity of salt, some quantity of sugar, or a glass of water. Because here it consists of protein, it consists of fat and the water. So the matter or the material which consists of more than one type of particles is called the impure matter. We will take another example, that is the salt water. A glass of salt water, it contains the two components. First component is the water, and number second is the salt molecules which are dissolved in this water. So here we have the H2O molecules and the NaCl molecules everywhere. If we will take some quantity at the top, at the bottom, here we will also have H2O plus NaCl, and in the middle we will also have the H2O plus NaCl. That means it consists of more than one type of particles. These are the examples of the impure matter. This impure matter is also called the mixture. Impure matter is also called the mixture. Why? Because it is the mixture of two or more substances or two or more constituent particles. As I already gave the example of the salt water, I give the example of the milk, we see more than one type of particles are present. So they make up the mixture. And the mixture is further classified into the two groups, that is the homogeneous mixture and heterogeneous mixture. Homogeneous mixture is the kind of the impure substance which contains the more than one type of particles, but the composition is uniform throughout that matter, throughout that medium, or throughout the material. Say for example, I am going to take the example of the salt water. This is the case of the homogeneous mixture. Here I am taking the salt water. So in this medium we have the two components, that is NaCl molecules and the water molecules, H2O plus NaCl. But the composition of the NaCl and H2O is uniform throughout. That means if here is a ratio 2:10 of water, of H2O and the salt molecules, here we will also have the ratio 2:10. That means the 2 NaCl molecules and the 10 water molecules. At this place we will also have this ratio 2:10 approximately. This will not be the exactly 2:10 everywhere. Somewhere they may be the 3:10, somewhere they will be the 1:10, 2:10, but average will be the 2:10. That means the 2 NaCl molecules and the 10 H2O molecules. So this composition is called the uniform composition. This is the one of the important property of the homogeneous mixtures, that the composition is uniform throughout the medium. Now heterogeneous mixtures. Heterogeneous mixtures are those which do not have the uniform composition throughout. Say I am taking the example of the water glass in which I dissolve the flour. This is the glass of the water in which I am going to trying to dissolve the flour. Here we have the water. When I dissolve the flour in this glass of the water, it will not dissolve completely. That means at the bottom we will see the higher concentration of the flour molecules. In the middle we will see relatively higher, relatively lower as compared to the bottom, and it will be the least at the top. Why? Because the flour molecules are heavier than the water and they will try to settle, and they are not mixing up completely and uniformly. So here we will get the more, say for example, the 1000 fluor molecules, and in the middle we will get the 500, and say at the bottom we will get the 100 particles of the fluor. That means there are physically distinct regions at different places in the material or in the matter, that is the mixture of the water and fluor. Here we have the higher concentration, here we have the relatively lower, and then here is the least concentration of the fluor in water. So there are the physically distinct parts in this mixture, and this mixture is called the heterogeneous mixture. And our second property of the heterogeneous mixtures is that first was the composition is not uniform. Number second property is the particle size is relatively more as compared to the homogeneous mixtures. Because in case of the homogeneous mixtures, when we take the example of the salt water, salt and water, here the salt molecules cannot be seen in the water because the size of the salt molecules is less than 1 nanometer, is less than 1 nanometer, so they are not visible. But in case of the fluor water mixture, here the fluor molecules can be seen with the naked eye, so they are visible to the naked eye, these molecules. This is the second property of the heterogeneous mixtures. But heterogeneous mixtures are further classified into the two groups. First, heterogeneous mixtures have further been classified into two groups. First is the suspension. Number second is colloidal solution. First, what is the suspension? We will talk about the suspension. Suspension is the mixture, a heterogeneous mixture, where the particle size is relatively larger and they remain suspended in the medium. I will take the example of the fluor water. Here we have the water, glass of the water, in which if we will try to dissolve the fluor molecules will remain suspended in the medium, or we can say they will remain hanged in the water. This is called the suspension. And particle size is large. Particle size is large. They remain suspended, or we can say they remain hanged in the medium. And when we direct the beam of light, for example, from here, if we will direct the beam of light from the torch, what will happen? The particles, fluor particles, are here large enough, and when the light photons will strike these particles, they will scatter the light, and in this way the path of the light becomes visible through the medium. And this effect is called the Tyndall effect. This is called a Tyndall effect. This name is after the name of the scientist who discovered first this effect, and therefore it is called the Tyndall effect. What is the Tyndall effect? It is just making the path of the light visible. Due to the larger size of the particles, they are able to scatter the light when a beam of the light is directed on the medium, on the mixture. This is called the Tyndall effect. So what are the characteristics or the properties of the suspension? First, the particle remains suspended in the medium. Number second, the particle size is larger. It is so larger that they can scatter the beam of the light when we direct the light on the medium, because the particles size is large, and they scatter this light and make the path of the light visible through the medium, and this effect is called the Tyndall effect. And fourth property of the suspension is that if we will left it undisturbed for some time, this is the suspension in which we have put the floor, that is the water in the floor. If we will left it undisturbed for some time, the floor particles which are suspended here will try to settle down towards the bottom. So after 2 or 3 hours, we will see at the bottom a thick layer of the floor has settled. That means they gradually move towards the bottom and settle at the bottom due to the gravity, because they are higher in weight and also the particle size is large as compared to the water molecules. This is the another characteristic, or we can say the property of the suspension. And number second type of the heterogeneous mixture is the colloidal solution. In this case, the particle size is relatively lower as compared to that of the suspension, but particle size is relatively higher as compared to that of the homogeneous mixtures or the solutions. For example, we are taking the glass of the water in which we will put the milk. This is the glass of water. This is the glass of water in which we are putting some drops of the milk or some drops of the ink. For example, we are putting the drops of the ink, let's say milk. What will happen? The milk will dissolve in the water, but not completely as in case of the homogeneous mixtures. So they are in midway. These solutions, or we can say that this type of mixture is in midway between the homogeneous and the suspension. What we see here in this colloidal solution, the particle size is large enough, but not as larger as there was in case of the suspension, but it is larger that they have the ability to scatter the beam of light. When we direct a beam of light on this solution, the particles are larger enough that they will scatter the light and make the path of the light visible. That means they will show the Tyndall effect. They will show the Tyndall effect. But if we will left it undisturbed for some time, the milk particles present in the water will not settle down towards the bottom. They will not settle down at the bottom. So milk particles will not settle at the bottom if we will left it undisturbed. So this property of the colloidal solution resembles with the homogeneous mixtures, because in case of the homogeneous mixtures, say we are taking the example of the salt water or the sugar water, they do not, the salt or the sugar molecules do not settle at the bottom. But in case of the colloidal solutions, the molecules also do not settle at the bottom. Only in case of the suspension, the molecules settle at the bottom. but not in case of the homogeneous solutions or the colloidal solutions. The only property of the colloidal solution which resembles with the suspension is that they show the Tyndall effect. That means they make the path of the light visible when we direct a beam of light on the medium. And another property is of the colloidal solutions that resembles with the homogeneous solutions is that if we will let this solution through the filter paper, if we will let this solution to pass through the filter paper in the separating funnel, what will happen? Here is the filter paper. We will not see any kind of residue here on the filter paper. That means the solution will thoroughly pass through the filter paper and reach the another container. This is the container first in which the colloidal solution was present. If we will let the solution to pass through the filter paper, this is the filter paper, this is separating funnel, what will happen? The residue will not settle here. We will not find any kind of separation, or in other words we can say we cannot separate the one component of the colloidal solution by passing the solution through the filter paper. But in case of the suspension, we can separate the component that we try to dissolve in the medium when we pass the solution through this filter paper. For example, in case of the suspensions, I have the floor water. I have the floor water in the glass. Here is the separating funnel, and here we keep the filter paper. And if we will let the solution to pass through the filter paper, here we are placing another container. The water will pass. Here is the water, H2O plus floor. The water will pass through the funnel, but the floor particles will settle here on the filter paper as a residue. This is called the residue. Floor will settle here as the residue, but the water will pass through this separating funnel and will pass to the another container here. So we can separate the component we are trying to dissolve in the suspension when we pass this solution through the pass this mixture through the filter paper. But in case of the colloidal solutions, we cannot do any kind of the physical separation. And another thing in which is related to these solutions, that is either homogeneous or heterogeneous, we have two components in the solution in each kind of the solution, whether it is the homogeneous, whether it is the heterogeneous. There used to be the two components. The component number one is called the solvent. Component number two is called the solute. What is the solvent and what is the solute? Say for example, I am taking the example of the glass of the water. The water, which is the medium in which I am trying to dissolve the salt, is this solvent. That means water, which is here H2O, it is the solvent, and the salt which I am trying to dissolve in this is called the solute. So every solution has the two components. One is the solvent, another is the solute. The solvent is the medium or the component which is present in the larger quantity, and the solute is the component which is present in small quantity. So solvent, larger quantity component, of the solution, whereas solute, it is the smaller quantity component. quantity component of the solution. As I give the example of the salt water, salt is solute and water is solvent. Why? Because water is present in the larger quantity and salt is present in the smaller quantity in the solution. This was our topic, first topic, that is the what is pure matter, what is impure matter, and how many types are there in the impure matter.